How to choose the current limiting resistor for a transistor switch circuit. This is a circuit for driving low-power devices with an MCU, using only a low-power lamp bead as a load. The circuit uses an NPN transistor, which acts only as a switch. When the transistor is used as a switch, it operates in saturation mode. The voltage between B must be greater than the turn-on voltage, and the voltage between B must be greater than the voltage between CE. The voltage between CE can be approximated as 0. When the MCU outputs a low level, the transistor is cut off and no current flows through the load. When the MCU outputs a high level, the transistor is saturated and conductive and current flows through the load. So how to choose the base current limiting resistor RB of the transistor? Assuming that the low-level output by the MCU is 0 volts and the high level is 3.3 volts, the conduction voltage drop of the lamp bead is 2 volts and its rated operating current is 20 milliamperes. Since the voltage between CE of the transistor is approximately 0 when it is saturated and conductive, it can be calculated that the current limiting resistor of the lamp bead is 150 ohms. In order to make the voltage between CE of the transistor as small as possible and make it in a deep saturation state, generally, the base current of the transistor is taken as 1/10 of its collector current, which is 2 milliamperes. The conduction voltage of the transistor is taken as 0.7 volts, so its base current limiting resistor RB can be calculated to be 1.3 kiloohms. Therefore, this circuit for driving a lamp bead through a transistor by an MCU is shown in this figure. If the collector current of the transistor is relatively large, IB may need to be greater than 1/10 of IC in order to make CE's voltage as small as possible. When MCU powers on, its IO status is generally input status. Therefore, in order to have a definite level when powering on, a pull-down resistor will be added to its base in a transistor switch circuit. Its value is generally 10 kiloohms. A 10 kiloohm resistor will divide about 0.07 milliamperes of current from its base, which can be ignored for its base current. It should be noted that there is a large margin for its base current limiting resistor calculated above when its collector current is not large. Therefore, within a certain range, increasing RB will still work in saturation mode.